Hi, welcome to the second video tutorial of the OSL Programming Notes add-on. Before we get started with things like functions, loops, and ray tracing, you need to know a little bit more about variable types. Cycles has got only 4 of them. You've got shaders, colors, vectors, and decimal numbers, which in programming are called floats. They can all be connected to each other, except shaders. And conversions are done automatically by cycles. Most of the time, that's great. You don't have to worry about that. But in OSL, things are a little bit different. Before we get to that, I want to show you a few examples of how cycles handles conversions. For example, from a color to a single value. As you can see here, I have got a white value plugged into the strength of an emission shader, and as you can see, it is pure white. If I do the same with a vector, also with all values set to 1, you get the same color. Now if I change this to, for example, blue by setting red and green to 0, you get a dark gray value, which is exactly what you'd expect. However, if you do the same with a vector, it's a different color all of a sudden. Colors and vectors aren't converted in the same way, apparently. Another example are vectors themselves, since they are not just vectors sometimes, they can also be points or normals. A point is a location in 3D space, a vector a direction, and a normal is a direction with the extra property of always having a length of 1. If I try to transform the normal from world space to object space, I have to say that it is a normal. And then you get the normal in object space. But if I try to transform it as a point, you get completely different and completely wrong values. When you're creating materials with this add-on, what you're basically doing is programming in the OSL language. The OSL language also has vectors, but there is a difference between points and normals. As you can see, vectors are also purple, only a little bit darker. Normals are dark blue and points are light blue. And vector math nodes have different input types. For example, the Fresnel node takes a normal, and you can plug in a point here if you like, just like you would with cycles, only it expects a vector with length 1. To show you why those input types matter so much, I have created a simple diffuse material in the OSL nodes, and I multiply the normal by 100. So all of a sudden it's a vector with length 100. And I've got the script node over here with this material selected, and I input the normal. And as you can see, instead of just white, it simply emits light because the normal is way too long. The simplest way to solve this, of course, is to just add in a vector normalize node, which resets the length to 1. As you can see, the output type of this normalize node is a vector. But although it is connected to the normal, it's still a vector with length 1. So the diffuse shader node will just see this as a normal. If I add the vector transform node, which in OSL is called the transform space node, you can see that there is no selection of type anymore as there was in cycles, because this node automatically sees whether it's a normal, point, or vector that is connected to it. So if I connect a point with it, it will know it's a point and transform it in the right way. When you connect a float value to, for example, a color or a vector, the node will simply see it as, for example, a color with RG and B set to 1. The vector will, of course, do the same. As you can see, some of the nodes have black inputs and outputs, and these are generic types. The most important example of this is the math node. When you add two things together, you can, for example, add together two floats. So if you do 1 plus 2, you of course get 3. Surprise. And when you compile the material, you can see that the color of these inputs and outputs changes. It has become a slightly transparent gray, the exact same color as the float value, of course. When you connect, for example, this normal and then add together, all of a sudden this input becomes blue and the output becomes blue as well. This is because this math node sees this normal and this float and guesses that you want to add 2 to the x, y, and z coordinates of this normal. The guessing of these types is called type inference, and it's very useful because of this, you don't need 2 different nodes for multiplying vectors and floats. In cycles, you have got the math node as well, but these are all float values, single values. So if you put in a vector over here, it first takes the average and then outputs a single value instead of a vector. A node can't always guess the correct output type. For example, when you add together a normal and a vector, as you can see, the output becomes black again. So it's a generic type. You know that it is a vector-like type, a point-like type, but whether it's a normal or a vector, the node doesn't know. Even though sometimes it is important, for example, with the transform space node. So if you want to specify the type again, you've got the convert cast node. And as you can see, it's got black inputs and outputs as well. But if I, for example, say I want this to be a vector, hit compile again, you can see generic, and now it converts it to a vector again. And the transform space node sees that it is a vector again. Not every conversion is allowed. For example, if I try to convert this to a float value, so this vector-like type with an x, y, and z coordinate to a single value, this output will turn red, and you can see an error over here. Could not infer types in the material in this node. That's because this node doesn't know how you want to convert 3 values to 1 value. You have to specify that yourself. To do so, you've always got the separate nodes, just like in cycles, or the color to black-white nodes. But you can also specify your own functions, of course. You've got several other types in OSL as well. The first example of this is the integer type. This is a whole number instead of a decimal number like the float. You've got a separate math node, although you can also use the basic math node. And whenever you, for example, connect an integer to, say, a diffuse shader, the roughness, this will simply get interpreted as a float, although of course you can't do 0.5. Later on, you'll see that the integer type is very useful for functions, if statements, and loops because you've got whole numbers which are much more precise than the float values. You've also got the matrix type, which can be used to transform vectors. You can either create a matrix by hand or use one of the transform matrices. There's, for example, the rotation matrix. If you combine this with a vector and the vector transform node, the transform matrix vector node, you can, for example, rotate this vector around one of the axes. In cycles, shaders can only be added together and mixed with the add shader and mix shader node. You've got these 2 nodes in OSL as well, of course. But you've also got the multiply shader node now. And with this node, you can multiply the output color of a shader with another color. For example, if I use this connect this diffuse shader with this multiply shader node and then multiply it with, say, blue, this white diffuse shader will of course become blue. Like I mentioned before, whenever you connect to nodes that aren't allowed to be connected, when you press compile, you'll get an error. If you don't want to compile but just check the types, there's an extra button for that. When you do that, no script node will be written. The socket will turn red and the error will be displayed over here.